Welcome to 5 Minutes to Code, Programming Basics with your host Matthew C. Applegate. In this series, we are going to look at the fundamentals of computer programming. So whether you are hoping to program in Python, to code in C#, or to develop in Java, these short guides should help you get to grips with the basics. You won't need to download or install any software, so just sit back and enjoy. In this series, we are going to be looking at binary, hexadecimal, data storage, logic gates, and logic circuits. Today, we are looking at hexadecimal. Let's look at this in more detail. In our everyday life, we use a number system called denary, 0 to 9. This is referred to as a base 10 system, and the units, the ones, the tens, the hundreds, and the thousands, etc., increase by the power of 10. 10 times 1 is 10, 10 times 10 is 100, and so on. Computers, however, can use a number system called hexadecimal, which uses 0 to F. This is referred to as a base 16 system, and its units, the 1s, the 16s, and the 256s, etc., increase by the power of 16. A computer can't actually read hexadecimal. It is converted into binary first and then read. Hexadecimal is often used as a midway point for humans to read instead of binary. Binary can be difficult in large chunks, so for some things, hexadecimal is used. Hex is used in all sorts of things, like color values in HTML, coding in machine code, and even hacking Game Boys. An example of hexadecimal would look like this: FF. The first F on the far right is valued at 15. The second F on the left is 15 times 16, which is 240. Add these two together and you get 255. Okay, let's convert a number. Let's try 138. We need to divide it by the largest power of 16. So 16 times 10 is 160, which is too big. So let's try 16 times 9, which is 144, which is still too big. So let's try 8 times 16, which equals 128, and that is perfect. So our first hexadecimal value is 8. We subtract 128 from 138, and we have 10 left over. So now we need to add 10 to the second value, and 10 in hexadecimal is an A. So our second value is A, giving us 0x8A. The 0x is a prefix to let the reader know that it is a hexadecimal value and not a denary value. In this case, it is clear that A is not in denary, but some hexadecimal values can just have numeric values, like 83 in hex is actually 131 in denary, and that is why we use the 0x prefix. Okay, let's try another one, 195. Okay, so 10 times 16 is 160. And that's not quite big enough. Let's try 11 times 16 is 176. But I think we can still go a bit bigger than that. So 12 times 16 is 192. And that's pretty close to 195. 12 in hex is C. So then we get the 195 and subtract the 192. And that leaves us 3. Unfortunately, 3 in hexadecimal is 3. So our hex value is 0xC3. And now, let's try and convert hexadecimal to denary. Yep, the other way around. This is quite straightforward. Let's try 0x94. So 9 times 16 equals 144, and we have 4, which is 4 in hexadecimal. So we add them together, and that equals 148. Pretty simple, huh? So there you go. That's hexadecimal. Remember to use the prefix to prevent ambiguity when writing down hex value. I hope you have enjoyed the video. If you have, be sure to subscribe to my channel, like the video, and comment below if you found it useful. If you want to get started in programming right away, be sure to check out my computer art programming tutorials here. Until next time, thanks for watching 5 Minutes to Code.